My name is Mr. Evangelista, and welcome to another episode of Evangelista Science. Today we're going to be doing the last lecture of the IB-Chem-SL curriculum for the Organic Chemistry chapter. Today we're going to be talking about halogen alkanes. Now first, let's define nucleophiles and electrophiles. So first we're going to talk about nucleophiles. These are species that are electron rich, and they are really good at attacking other molecules, especially ones that are electron deficient. And so here we see an halogen alkane that is some type of halogen, a group 17 molecule bonded to a carbon atom. And so you can see that the electronegativity of the chlorine is a lot greater than the electronegativity of the carbon. So what tends to happen is you get this partial negative on the chlorine and the partial positive on the carbon. Now sometimes the chlorine is so electronegative that it actually pulls a lot of the polarity towards it, which leaves this kind of electron deficient portion right here on the carbon. And this is a prime target for a nucleophile. Now, one of the nucleophiles that we can have is a hydroxide molecule. Hydroxide molecule is electron rich. It's got it's got a lot of electrons around it, and so what it will do is it can actually attack these electron deficient regions. And that is evidenced in this equation here, where we have chloromethane, and we have a strong nucleophile, such as sodium hydroxide, which gives the OH. What will happen is that hydroxide will attach that electron deficient portion of the carbon. It'll kick off the chlorine, because chlorine wants to take those electrons. It has a high electronegativity, and so we get the molecule like methanol. This can happen with other alkanes as well, with any of the halogens. And so we see here we have bromopropane with alcohol with an OH, and we get propanol. Benzene reactions. So if a nucleophile has an abundance of an electrophile is an electron deficient species, and it accepts an electron pair from nucleophiles. And electrophiles are also positive and have a partial positive charge. And so we see here we can actually do addition reactions to benzene. Benzene is reluctant to go under addition reaction. Sorry, it's not addition, it's a substitution reaction. So it's more likely to go through a substitution reactions than an addition reaction. That is because benzene is super stable. And so we cannot add anything into the ring. However, we can substitute the hydrogens outside for other species, but we cannot add anything into the ring. So it's unlikely to go through addition, but it is likely to go through substitution between these H's. So you can see here that we can replace each of these hydrogens with some type of electrophile. So we can add this NO2 group to the benzene ring. The catalyst for this is concentrated sulfuric acid with about 50 degrees Celsius, and we just add nitric acid to that to add an NO2 group to the benzene. We can also react them with halogens. So if I wanted to add a chlorine group to this benzene ring, I do aluminum chloride, AlCl3, in dry ether, and that will add a chlorine to the benzene ring.